Hi Geometry. This is our Unit 4 Lesson 4 notes on Intro to Trigonometry. These are half sheets that I passed out in the classroom. If you were absent, they're in our folder, both blank and filled in. You could put them at home. You could write on your own paper. You could message me to leave a set for you in the main office, or you can get them when you return. When we're working with trigonometry, sometimes you're going to see a variable besides x and y. Sometimes you'll see a variable that looks like this. It's a circle with a line through the middle, and it's pronounced theta. We'll take a look at that on page 2 of our notes. But for right now, I want to talk about this phrase, Sohcahtoa. Sohcahtoa helps me remember my three trig functions, which are sine, cosine, and tangent, that we're going to be working with. The S stands for sine, the C stands for cosine, the T stands for tangent. So the OH part tells me which sides of the triangle I use to compute sine. I use O for opposite over the hypotenuse, that's the H. The AH tells me that cosine, the one that starts with C, is adjacent over hypotenuse. And the OA tells me for tangent, I want to use opposite over adjacent. So what does this look like in a triangle? In this example, we want to find sine A, cosine A, and tangent A. We're going to express the ratio as a fraction and a decimal. So to begin with, if you're going to find sine of A, you got to start with angle A. That's my angle. Let's mark it. So I'm focusing on A. Angle C is my right angle, and angle B is just my other acute angle in my triangle. Let's label my three sides opposite, adjacent, and hypotenuse. So as I look at A, the side opposite is the side that doesn't touch it. That would be the 5. And then adjacent and hypotenuse both touch A. And so one way to keep it straight, which is which, the hypotenuse is always across from the right angle. And the adjacent side is the other leg touching your right angle, because to be adjacent means to touch. So I would identify your hypotenuse, and then that other leg has got to be your adjacent side. So let's start with sine. Sine is OH, so that's opposite over the hypotenuse, or 5 over 13. Let's also write that as a decimal. So we're going to do 5 divided by 13, and we get 0.384 or 0.385 or 0.39. I'm really okay with however you want to write it. I'm not particularly concerned about the decimals. So cosine A. Cosine is CAH, C-A-H. It's adjacent over hypotenuse. So my adjacent side is 12. My hypotenuse is 13. And when you divide those on your calculator, you get 0.923, 0.92. Tangent, Sohcahtoa, tangent is OA, so that's opposite over adjacent, or 5 over 12. And when you divide 5 over 12, you get 0.417 or 0.42, however you want to write that. So now it asks me to do the same thing for angle B. So I'm going to redraw this triangle, because when I move to the other acute angle in my triangle, there's two acute angles. There's one right angle, that's C, and A and B are my two acute angles, meaning they're less than 90. When I move to the other acute angle, all my sides change. So now let's focus on B. Let's mark angle B. Now I'm going to again label my sides opposite, adjacent, and hypotenuse, but this time in reference to angle B. So 12 is my opposite, 5 is my adjacent, 13 is my hypotenuse. Now I'm going to go through and do my sine, cosine, and tangent ratios again. So my sine ratio is OH, or opposite over hypotenuse. So the sine of B would be 12 over 13, which is 0.92. Cosine of B is adjacent over hypotenuse, which is 5 over 13, which is 0.39. And tangent of B would be opposite over adjacent, which is 12 over 5, or approximately 4.2. There's some relationships I want to discuss that you see here. So first of all, angle B and angle B and angle A are complementary angles. That means that they add up to 90 degrees. We learned that in Unit 1. And so if you notice, the sine of B and the cosine of A are equivalent. And the same is true for the sine of A and the cosine of B. This happens because they're complementary. And we'll talk more about this in a later lesson. Notice that there's a relationship between tangent. Tangent is reciprocals of each other. Tangent A is 5 over 12. Tangent B is the reciprocal, or 12 over 5. And that always exists for the two complementary angles of a triangle. By the way, we never do our trig functions to our 90-degree angle. We don't do the sine, cosine, or tangent of C when I'm working in a right triangle. We only do our sine, cosine, and tangent functions to the two acute angles in my triangle. Let's take a look at page 2. On page 2, we're going to be using our new sine, cosine, and tangent to find missing sides. So this is how I find missing sides. In right triangles, we're going to use our trig to find missing sides and missing angles. So this is the page on missing sides. We're going to locate our angle and label our sides opposite, adjacent, and hypotenuse in relationship to the angle. Then we got to pick out our sine, cosine, or tangent, and then we're going to solve. So sometimes I like to write my Sohcahtoa at the top of the page. It helps me remember which trig function I want to use. So let's look at number 1. I have to find x, and I'm given 21 degrees. This is step 1. Let's locate our known angle. This is the angle I know. I'm going to label all my sides based on it. This is opposite, this is my adjacent, and this is my hypotenuse. Now, I've got to determine whether I'm going to use sine, cosine, and tangent. So I study my triangle. I don't know the adjacent side. I want the opposite side, and I know the hypotenuse. So let's go find a trig function with the opposite hypotenuse, OH. And it looks like that's going to be sine. So sine of my angle equals opposite over hypotenuse. Now this is where I do step 4. This is where I have to solve for x. So I have x divided by 12. Let's multiply that 12 over. And on the right side, I just have x. Now this is 12 times sine of theta. So depending on which type of calculator you're using, you enter it differently. I have a whole video in our folder. It's one of the first things in our folder that says how to do trig on your calculator. You might want to watch that video for extra support here. On this style of calculator, I have to put the 21 in after the sine. So I'm going to do 12. You could press the times button or not. Your calculator will multiply whether or not you hit the times symbol. Sine, notice it opens with the word sine in parentheses. I'm going to put the 21 inside, and I'm going to hit equals, and I get 4.3. Notice down here at the bottom of this calculator it says degree. If the bottom of your calculator says radians, R-A-D, you need to use this degree button to switch it to degrees. Press it until you see DEG, because I'm working in degrees, 21 degrees, and you should get 4.3 for your answer. So let's write that down. Now this calculator works a lot like your iPhone calculator does. You've got to put the number in before you do sine. So whether you're working on this calculator, your iPhone calculator, your steps are 12 times. So you got to hit times. Now to do sine of 21, I'm going to put the 21 in first and touch the sine. Now that's not my answer. That's the sine of 21. So I'm going to hit equals. That's going to then multiply by that 12 I put in there. I get the same 4.3. Again, you have to be in degree mode, DEG. If you've got a different answer and this says RAD up here, use your degree button, press it until you get to your degree mode. And my answer is 4.3. If you want to know how to do this on your iPhone, please watch the corresponding video. Let's look at example 2. So in this problem, step 1 is locate my angle. There it is. Step 2 is label my sides. So I have my side opposite, I have my hypotenuse across from my right angle, and I have my adjacent side that touches it. So there's no opposite side in this problem. So I need a trig function that uses adjacent and hypotenuse. Adjacent AH, adjacent hypotenuse. Oh, it looks like it's cosine. So cosine of 42 equals adjacent 20 over hypotenuse. Now let's look carefully at this fraction. My x is in the denominator. I do not want my x, my variable, in the denominator. I'm going to multiply both sides by x. The point of this is to get it out of the denominator. But now I have x times cosine 42. Cosine 42 is just a number. So now I'm going to divide both sides by cosine 42. When I do that, I get x on the left side. On the right side, because my x's have canceled, I have 20 divided by cosine 42. So let's do that on our calculators. First, on this calculator, you enter your 20 divided by, and now I'm going to do cosine of 42. Cosine 42 and hit equals. And I get 26.9. Let's not round. We're going to keep 26.9 or even 26.91. Whichever one you want to write is fine. Let's take a look at this on this calculator. So on this calculator, I'm going to put the 20 in and divide by. But now to do cosine of 42, I have to type the 42 first, cosine second. That's not my answer. That's just my denominator. So let's hit equals. And that's my 26.9. That's my hypotenuse right here, 26.91. Down here are 3 practice problems that you can try. The answers are in our folder. It's titled Unit 4, U4L4, Unit 4, Lesson 4, Half Sheet Notes. So try to set these up, solve for your answers, check your answers to see if you're correct. This was page 2. Page 3 is going to be a second video. Thank you so much.